Hi, for today I am going to tackle about the derivation of parameters. So let's proceed to the given problem number 6, which is the quantity of d squared plus 2d plus 2 multiplied by y is equals to e to the negative x cosecant x, or simply the quantity of y double prime plus 2y prime plus y is equals to e to the negative x cosecant x. So we have the auxiliary solution, which is m squared plus 2m plus 1 is equals to 0. The quantity of m plus 1 squared is equals to 0, and the quantity of m plus 1 squared is equals to negative 1, and m plus 1 is equals to positive or negative I, and m is equals to negative 1, positive or negative I. So we have the characteristic equation, which is y sub c is equals to c sub 1 e to the negative x cosine x plus c sub 2 e to the negative x sine x. So we have the particular solution, which is the y sub 1 is equals to e to the negative x cosine x, and y sub 2 is equals to e to the negative x sine x, and we have the g of x, which is e to the negative x cosecant x. So we have the Wronskian method in order to get the u sub 1 and u sub 2, which is in need for the particular solution. We have w to the quantity of y sub 1 and y sub 2, which is y sub 1, y sub 2, y sub 1 prime, y sub 2 prime is equals to the value of y sub 1 is equals to e to the negative x cosine x, and the value of y sub 2 is equals to e to the negative x sine x. And the y sub 1 prime is e to the negative x cosine x, negative e to the negative x sine x. And we have the value of y sub 2 prime, which is the e to the negative x sine x, e to the negative x cosine x. So we have the w to the quantity of y sub 1 and y sub 2, which is negative e to the negative 2x cosine x sine x plus e to the negative x cosine squared x plus e to the negative 2x cosine x sine x plus e to the negative 2x sine squared x. So we already eliminated, so the value is w to the quantity of y sub 1, y sub 2 is equals to e to the negative 2x cosine squared x plus e to the negative 2x sine squared x. So we have the value of e to the negative 2x to the quantity of cosine squared x plus sine squared x. So we have the e to the negative 2x multiplied by 1. So the result is e to the negative 2x. So we need to get the y sub 1, the w sub 1, and w sub 2. For the w sub 1, we have the equation, the absolute value of w of 0, y sub 2, g of x, and y sub 2 prime. So 0 is to 0, and y sub 2, the value is e to the negative x sine x, and g of x, which is e to the negative x cosecant x, and y sub 2 prime is 2 negative e to the negative x sine x plus e negative x cosine x. So we have e to the negative 2x cosecant x sine x is equals to negative e to the negative 2x sine x, 1 over sine x, and we have the value of w sub 1, which is negative e to the negative 2x to negative 1. So we have the w sub 2, which is the absolute value. So we have the absolute value of y sub 1, 0, y sub 1 prime, and g of x, which is the value of y sub 1 is e to the negative x cosine x, And for the y sub 1 prime is e to the negative x cosine x, negative e to the negative x sine x. And we have the value of g of x, which is the e to the negative x cosecant x. So we have the result of e to the negative 2x cosine x cosecant x. So w sub 2 is equals to e to the negative x cosecant x, and cosine x is equals to to the negative x cosine x 1 over sine x. So we have the value of w sub 2, which is e to the negative 2x cosine x sine x. So we need to get the w to the u sub 1 and u sub 2 rather. So we have the u sub 1 is equals to the integral of w sub 1 over w dx is equals to the integral of the value of w sub 1, which is negative e to the negative 2x negative 1, and the value of w, which is e to the negative 2x dx is equals to negative integral of dx, which is the x is a constant and it results to negative x. And for the u sub 2, which is the integral of w sub 2 over w dx is equals to the value of w sub 2, which is e to the negative 2x cosine x sine x over the value of w, which is e to the negative 2x dx. So the result is the integral of cosine x over sine x is equals to ln the absolute value of sine x. So we have the formula for the particular solution, which is the y sub p is equals to u sub 1, y sub 1 plus u sub 2 and y sub 2. So we have the value of u sub 1, which is the negative x. And the value of y sub 1, which is e to the negative x cosine x, plus the u sub 2, which is the ln sine x, and the value of y sub 2 is equals to the quantity of e to the negative x sine x. So we have the particular solution result. The y sub p is equals to negative x e to the negative x cosine x plus e to the negative x sine x ln sine x. So in order to get the general solution, we need to add the characteristic equation and the particular solution. So we have the y is equals to c sub 1 e to the negative x cosine x plus e sub 2 e to the negative x sine x minus x e to the negative x cosine x plus e to the negative x sine x ln sine x. So this is the result. And I hope you enjoy and you have the knowledge about this presentation, and thank you.
Hello guys, I am Kyla Ganarkanjan. For today's video, I'm going to give you an example for solving for non-homogeneous second order differential equation with the use of the method of coefficient. So let me give you an example. Say we have y double prime plus 4y prime plus 3y equals 6. So the general solution for the non-homogeneous differential equation is y equals y sub c plus y sub p, wherein y sub c is the complementary solution and y sub p is the particular solution. So the first thing that we should do is to determine the associated homogeneous equation for this non-homogeneous equation. So since we are looking for the associated homogeneous equation of this non-homogeneous second order differential equation, we are going to set the other side of the equation equal to 0. Like that. So the characteristic polynomial for y double prime plus 4y prime plus 3y is, let's say, y equals r. So r squared plus 4r plus 3. In order to solve for r, we are going to factor the quadratic polynomial equation. So like this. R plus 3 and r plus 1 equals 0. So set each factor to 0. So r plus 3 equals 0, so r equals to negative 3. R plus 1 equals 0, so r is equal to negative 1. Therefore, the result then tells us that our complementary function or our complementary solution is y sub c is equal to c sub 1 times e raised to negative 3x plus c sub 2 times e raised to negative x. So this will be our complementary solution. So after we already solved or we've looked for the complementary solution, so next let's look at the right side of the equation, this. So as what we can see, our g of x is 6. 6 is a constant, right? So that means that the particular function for this non-homogeneous equation should be a constant also. So we set the particular function as some constant a. So let's just use a. So we are going to derive y double prime plus 4y prime plus 3y. So since our particular function or particular solution is some constant, therefore the first derivative of yp is equal to 0, as well as the second order derivative. It's also 0. Yes. So using these informations, we are going to plug it or to plug those in our equation, and we are going to solve for a. So this is how it looks like. 0 plus 4 times 0 or 4 times 0 plus 3a is equal to 6. So 3a equal to 6. Multiply both sides by 1/3. 1/3. So a is equal to 2. Therefore, our particular solution for this non-homogeneous differential equation would be 2. Since we already got the complementary solution and the particular solution for this non-homogeneous second-order differential equation with the use of method of coefficients, so now we can plug it into the general solution to get the general solution for this non-homogeneous second-order differential equation. So y equals sub c plus p. Therefore, our general solution for this is y sub c, which is c1 times e raised to negative 3x plus c sub 2 times e raised to negative x plus our particular solution, or y sub p, which is 2. So for this non-homogeneous second order differential equation, this will be the general solution with the use of method of coefficient. So thank you for watching.
Now I'm going to talk about one of example of non-homogeneous in differential equation. So the example is y double prime plus 3y prime plus c is equal to cosine x. So we have a r squared plus br plus c is equal to 0. Then since our a is 1, so we will have a 1 times r squared plus br, which is equal to 3. So 3r plus c, which is equal to 2, is equal to 0. So we're going to factor out this. So we have r plus 1 times r plus 2 is equal to 0. So we're going to find the value of r sub 1 first. So transpose it to the other side. So r1 is equal to negative 1. Then this r sub 2, transpose it, so it will become r sub 2 is equal to negative 2. So now we have a general solution of yc is equal to c sub 1 times e raised to r sub 1 times x plus c sub 2 times e raised to r sub 2 times x. So we will substitute it, the value of r1 and r2, or r sub 1 and r sub 2. So we have the final general solution of yc is equal to c sub 1 times e raised to r sub 1, which is equal to negative 1. So negative 1 times x is equal to negative x. So then plus c sub 2 times e raised to r sub 2, which is equal to negative 2. So negative 2 times x is equal to negative 2x. So we have a general solution of yc is equal to c sub 1 times e raised to negative x plus c sub 2 times e raised to negative 2x. So that's our general solution. So after having a general solution, so we will continue it in this type of solution. So since our g of x in the problem below is cosine x, so first we will find the y sub p, or y is equal to a. So before that, y sub p, it must have a expression of cosine and sine x, cosine and sine. So y is equal to a cosine x plus b sine x. So the derivative of a cosine x is negative a sine x plus the derivative of b sine x is b cosine x. So we have already the y prime. Then when having the double prime, so we will find the derivative of the y prime. So the derivative of negative a sine x is equal to negative cosine x. Then the derivative of b cosine x is equal to negative b sine x. So after getting those information below, so we will going to substitute this information to this or this. So in the problem below, y double prime, so the y double prime there will be negative a cosine x minus b sine x. So we will put it here. Plus 3 times y prime, which is equal to negative a sine x plus b cosine x. So here. Plus 2y, or y is equal to a cosine x plus b sine x. So here, 2 times the quantity of a cosine x plus b sine x is equal to cosine x. Then, we will find first the combined like terms, or we will combine like terms it. So, first, we'll find the same term of a cosine x. So, the same term of a cosine x is here. So, negative a cosine x plus 2 times a cosine x is equal to 1a cosine x. Then, we'll find the cosine x. So, or we'll find the b cosine x. So, where is the b cosine x? Here. So, 3 times b cosine x is 3b cosine x. Plus, we'll find the b sine x, which is here. Negative b sine x and 2 times b sine x. So, negative b sine x plus 2 times b sine x is equal to b sine x. Then, we'll find the a sine x, which is here. 3 times negative a sine x, so negative 3 sine x is equal to cosine x. Or we can have it like this. 1 cosine x plus 0 sine x. Since cosine x is have a 1 here, so we can put 1 here. Then plus 0 sine x, since it doesn't have sine x, so we can put 0 sine x. So that we later on we can simply solve the problem below. So next is, so we're going to factor out this since they have the same terms. So since 1a cosine x plus b plus 3b cosine x have the same terms, which is cosine x, so we can factor it out. So it will become a plus 3b times cosine x, then plus sine x, then sine x. So we can factor out since they have the same terms. So b minus 3a times sine x is equal to 1 cosine x plus 0 sine x. So after that, we're going to have a method which is called elimination. So a plus 3b is equal to 1. Since here is a plus 3b cosine x, then is equal to 1 cosine x. So we'll put a plus 3b here is equal to 1. 1 is here, the cosine x here. So we're going to eliminate it. So it is here. Then we copy the coefficient or the sine x here. So b minus 3a, then 0. So we will put here negative 3a plus b is equal to 0. b minus 3a and negative 3a plus b are the same. I just interchange it. So when having an elimination method, it will become simpler. So here. So we can multiply the both side by 3 here so that it will be simpler. So 3 times a is 3a, 3 times 3b is 9b, then 3 times 1 is 3. So here. Then bring down the sine x. So 3a minus 3a, or 3a plus negative 3a is 0. So cancel out. Then 9b plus 1b is 10b. Then 3 plus 0 is 3. So our b here is 3 over 10, since we will divide this both sides by 10. So cancel out, then 3 over 10. So b is 3 over 10. Since we have the value of b, so we can now find the value of a in this solution, or in this formula, or in this expression, which is here. Where it is here. A plus 3b is equal to 1. So we can use it to find the value of a. So here, a plus 3b, which is b is equal to 3 over 10 is equal to 1. Then a plus 3 times 3 over 10, which is 9 over 10, is equal to 1. Or we can simply make it as 10 over 10 to make it easier later when we solve it. So a is equal to 10 over 10 minus 9 over 10, which is equal to a is equal to 1 over 10. Here. So we have the value of b and a. So now since we have the value of a and b, so we can now substitute it in the solution, or in the solution here. Sorry. So now we have this. So yb is equal to 1 over 10 cosine x plus 3 over 10 sine x. So we will factor out, since they have similar here, the 1 over 10 and 3 over 10. So we can factor it out. So it will become y sub p is equal to 1 over 10 times cosine x plus 3 sine x. Then y sub or yc is equal to c sub 1 times e raised to negative x plus c2 times e raised to negative 2x. This is our general solution above. So that is our general solution. So now we find the value of y. Then in finding the value of y, it is equal to y sub c plus y sub p. So now we have already the y sub p, then y sub c, or yc. So we're going to add it to have the value of y, or to have the final answer. So y is equal to c sub 1 times e raised to negative x plus c sub 2 times e raised to negative 2x plus 1 over 10 times the quantity of cosine x plus 3 sine x. So that is our final answer.